Hello mathematicians, thank you for joining me today as we look at the problem of finding the absolute extrema of f of x equals x cubed minus x plus 2 on the interval 0 to 3. So what we want to do is we want to find the biggest y value and the smallest y value that occur for the function on the given domain, which is 0 to 3. Now if we recall, if we're trying to find absolute extrema, remember that absolute extrema necessarily are local extrema. Local extrema necessarily occur at critical points, so therefore we'll have to find the critical points if we're going to find the absolute extrema. Now the other thing we know about this problem is that this is a continuous function because it is a polynomial, and this is a bounded, closed bounded domain. So because of that, what we know is that this has to have an absolute max, it has to have an absolute min on this given domain. So what we need to do then is say, well, it has to have a max, it has to have a min. Both of those have to occur at the critical points. So what we can do here is find all the critical points and then find the y values. Whichever one's the biggest will be our absolute max. Whichever one's the smallest will be our absolute min. So there's an outline of the process. So now we'll actually work through that. Alright, since we're going to need to find our critical points, we're going to need to find our derivative, because we have to find one that's 0 or undefined. So if I want to find my derivative, I'm just going to say my derivative is, well, the derivative of x cubed is 3x squared, and then the constant 1/3 I can factor out, so I'm going to end up with 3x squared over 3, which is just going to be x squared. The derivative of negative x is -1, and the derivative of 2 is just 0. And so what I end up with is, this works out to being, my derivative is just x squared minus 1. Now to find my critical points, what they need to do is find where this is 0 undefined. So if I want to find where it's 0, I'm just going to let 0 be x squared minus 1. So 0 is x minus 1 times x plus 1. And so x minus 1 is 0, or x plus 1 is 0. So x is 1 or x is -1. Now I want to start off with this one because we can solve that fairly quickly. We get out that our derivative is 0 at 1 and -1. But what I want to point out here is that in order to be critical points, they need to be in the domain. So notice that 1 is in the domain because our domain is 0 to 3. And again, this is a continuous function on that domain. So this would be a critical value. We would have a critical point there. On the other hand, -1 is not in this interval, therefore it's not in the domain. Now because I've defined this function on this interval, that means that it's only defined for these numbers. Therefore the function's not defined at -1. Therefore our derivative can't be defined at -1. Therefore we can't have a 0 derivative here. So we don't include this one as a critical value. We would just have x equals 1 be a critical value. Now for the next thing, I need to find where my derivative is undefined. And again, I'm going to point out here that my function is only defined on 0 to 3. So my derivative is actually undefined anywhere but 0 to 3. So at -5 and -6, my derivative is undefined. Again, those can't be critical points because they're not in the domain, so we're going to ignore most of those, but there's a couple points that this is important at. And so what I'm going to do is, I'm not going to draw our function, but I'm going to imagine I have a function on the interval 1 to 3. And so it's defined and continuous, and so it looks something like that. So now the point here is that what happens right at 3 is if I try to draw a tangent line, the way I would do that is by drawing secant lines. And so I can imagine a secant line, and I can get closer and closer, and then I get a tangent line that looks like that. Now notice that that was drawing secant lines from the left hand side and letting those get closer and closer because the tangent is the limit of the secants. So I took that from the left and I got that out. However, if I try to do the same thing from the right, notice that if I try to draw a secant line from over here, that means I have to pick a function value over here, draw through this point here and make a line, but over here I have no function values. Again, my domain's only 0 to 3, so there are no function values over here. So if I try to draw a secant from the right, that's not possible. Since I can't draw the secants, I can't take the limit of the secants. Therefore, I don't have the tangent line from the right. So what I get is that the limit from the right of the secant lines does not exist. Because the limit from the right doesn't exist, that means the two-sided limit doesn't exist. Therefore, my tangent does not exist. Because my tangent does not exist, that means that my derivative does not exist. Hence, we have that f prime is undefined at x equals 3. And now, furthermore, well, we also said it was undefined at 4 and 5. At 3, though, 3 is in the domain because it's in the interval 0 to 3 because we're including 3. Because 3 is in the domain, it is a critical value. Our derivative is undefined. We're in the domain, so we have a critical value at x equals 3. If we do the same thing again, we're going to get a similar result coming to 0. That is, from the left, we can't find secant lines, even though we can from the right. So we would say that the derivative is also undefined here because the two-sided element does not exist. So we'd also get our derivatives undefined at 3 and 0. And so in general, if we have an interval here, our derivative will be undefined at the endpoints because we won't be able to find the slope of the tangent line. Now that we found where our derivative was 0 undefined, we have all of our critical values, and we found that the critical values were at x equals 0, x equals 1, and x equals 3. So what we decided before was that, well, this has to have an absolute max and absolute min, and it has to occur at a critical point, so it would have to occur at one of these critical values, 0, 1, and 3. So if I want to find the max and min, I just need to find the biggest y and the smallest y values at those 3 points. So now instead of having to look at all the points between 0 and 3, I just have to look at these 3 points. So now if I'm going to compare them, the easiest way to do that is to make a table. And so I'm going to have my x values and my y values. And I'm going to have 0, 1, and 3 are the ones I'm interested in. So I'm just going to find the function value at each of these because I want the y values at each of them. So if I find f of 0, I get 0 minus 0 plus 2 is 2. If I find f of 1, I get 1/3 minus 1 is negative 2/3 plus 2 is 1 1/3 or 4/3 we'll say. And if I use 3, I get 3 cubed is 27 over 3 is 9. 9 minus 3 is 6 plus 2 is 8. And so, to figure out what is my absolute max and absolute min, I'm just going to look at what's biggest and what's smallest out here. And so, if I compare these, notice that the 8 is the biggest. So that's going to be my absolute max. And the 4/3 is the smallest out of those 3 because 4/3 is less than 2. So that will be the absolute min of the function. And so what I would say is that I have an absolute minimum of 4/3, and I can say at x equals 1, and an absolute maximum of 8 at x equals 3. So now I want to point out here that it's absolute minimum of 4/3, that is the min is the y value. Now we can say that occurs at x equals 1, and that's worth noting, but the actual minimum value is the 4/3 y value. Same way, the absolute maximum is the 8. That's the biggest my function gets. But then we could say it occurs at x equals 3, but the y value is the absolute maximum. Thank you for watching. As always, I hope you learned something today, and I hope you enjoyed the process along the way. If you did, make sure to like the video and subscribe to the channel. It helps me to know which videos are helpful, and it helps other people to find these videos so that they can also get help. Thank you.